Dear students, in this section, we are going to learn about assignment S18, which is present value and future value analysis using Microsoft Excel. The first question is, do you need to understand all the details about the present value, future value calculation and its relation with the future assignments which are coming? That is net present value, internal rate of return, and finally, the last two most important, which is financial what if analysis and financial statement preparation. Yeah. So the question is, do you really need to understand all the details as a part of this assignment? Well, the answer is no. Initially, for the first 7 to 10 minutes, I'm going to give you an overview of what these terminologies are, followed by a systematic assignment solving. And that knowledge should be more than sufficient for you guys to understand the whole concept and how to use the right syntax, right formula in Excel to get the complete analysis done. And this is the exact type of analysis industry uses for their all their like monthly, quarterly, half yearly, annual financial statement preparations and reviews. So moving forward. So in this section, we are going to learn about how we can calculate the present value and future value from each other, and how we calculate the future value from the present value using simple Microsoft Excel formulas. But before we go there, I understand you do not understand all the details in this well state, or yeah, like since you guys, most of you are new students who haven't taken any classes in financial analysis or accounting. So I'll give you a short overview. Now let us start by learning these two important terminologies. It all starts with the concept of time value of money, which simply means that say $1. Yeah, so $1 today has more value than $1 in the past. After some time, maybe over a year or two or even more years down the line, in different periods of time, the dollar value, like yeah, again I will repeat, dollar value today will be greater than dollar value at some point in the future. Yeah, and as of now, just like yeah, get to this basic. I'll give some more illustrations to elaborate what that means. Yeah, so let me give you an example. Let's say today you can buy this bag, yeah, one bag of groceries for $100. And suppose the inflation rate, the annual inflation rate, I will say last couple of years has been high. So I'm counting it as high, say 6%. So for the next year, the rate of inflation is 6%. It means that after exactly 1 year, to buy the same bag of groceries, you will need $106. Yeah. So again, the content of the bag, quality, content, yeah, quantities of whatever groceries are there inside remain the same. So exactly same content here that is in this content. But today I'm able to buy it for $100, and exactly 1 year from now, if I have to buy the same content, I have to pay $106. Yeah. So yeah, $6 more would be required to buy the same bags. So we can conclude that $100 today is equal to $106 after exactly 1 year, because the value that you can buy with $100 today is going to be the same that you will buy for $106 in the future, that is 1 year. So technically, if you account the inflation, these two are equal, yeah. So this $100 equals to $106 with respect to the content that you get for this much amount, yeah. Or alternatively, we can say that $100 today is bigger than yeah, bigger in its value as compared with a year later, because of this terminology called as inflation. Now, the next key question here is to how we convert present value into future value. Yeah, so there's a key question over here, and there's the main content over here. There's the main topic we are learning as of now. And to understand that, we are going to start with a very simple scenario out here. So what is going to be the amount like yeah, after a few years? So we are going to say we have $1,000 today, 1,000. and we are going to deposit in a bank for 5 years. Yeah. So suppose the term is 5 years, and I'm going to put in a savings account. And the bank interest rate, so again, it is offering very high interest rate of 10%. So what is going to be the amount after 5 years? Yeah, so that's the main question we are trying to solve. And for that, we have to understand the interest, how it applies. Yeah. And again, there are two types of interest. One is simple and one is compounding interest. And I'm going to talk about it in few minutes or few seconds. So when we talk about interest, yeah, the two types are simple interest. Yeah, that's the first one. So what that means is that you will be earning 10% interest here for the one entire year. So again, if I start with year one, I'll be earning 10% of 1,000, that is $100. And if I use simple interest, again, I won't be adding. So for the year two also, I'll be using the same $1,000 multiplied by 10%, which is zero point 0.1, gives me $100. Same thing for year three, year four, and year five. Yeah. So with that logic, I'm earning $100. That is, 1,000 multiplied by 0.1, $100 multiplied by 5 times. So that gives me $500. Yeah. So again, today the amount I have is 1,000, and the amount after 5 years, I'll be having $1,500, and that's the logic over here. That is simple interest. I'm only multiplying this interest with the my basic amount, that is I'm having today. Yeah, so that's my simple interest. So in other words, I can say that with a simple interest, my $1,000 today will automatically become 1,500 in 5 years. But now there is another type of interest as well, and that is called compound interest. So let us take the same scenario with the compound interest. Yeah. So again, the amount I have is $1,000. The bank is offering 10% interest rate if I put it in a savings account. And the term I'm putting in the savings account is for 5 years. So I have to use compound interest methodology, and I need to know the value of all my amount today with these conditions after 5 years. Yeah. So that's the problem I try to solve using compound interest method. So with compounding, we would say that in year one, the balance at the beginning that you have just deposited into the bank is 1,000. And on that 1,000, you are going to earn 10% interest. Yeah. So year one balance 1,000, interest paid, which is 1,000 into 10%, which is $100. So end of year one, the balance I'm getting is $1,100, which is, yeah, simple addition of my basic amount plus the interest earned. So this is the balance at the end of year one. So at the start of year two, this will be my new balance that will go into at the start of year two. So which is $1,100. And on this $1,100, I'll be earning 10% interest. So that gives me $110. So at the end of year two, using my compound interest formula, I'm earning 1,100 plus 110, which is $1,210. So by end of year two, this is the amount I will have. Now for the start of year three, this is the amount that will go in the start of year three. So that is 1,210. And I will multiply this 1,210 with 10% interest. That gives me $121. So at the end of year three, I'll have this much amount. And this will be my starting point for year four. I will multiply this by 10% again. That gives me $133.1. So at the end of year four, I'll be having this much amount. That is addition of start plus interest earned for the same amount. And here, so that's $1,464.1. And my beginning of year five, this will be my starting point. I'll multiply it with 10%. So this is my end balance I have. So again, if I add these two up, I get $1,610.5. Yeah. So this is the amount I get using compound interest formula. And again, on the similar note, this is the amount I get using simple interest formula. Yeah. So oftentimes these are two very important, simple looking, very simple the terms, but these are very, very important in industry terms. These are the two very important. And eventually compound interest is the one that is most applied. And again, in industry terms, yeah, in all the financial statement, this is the term that they are using. And at some point, even you guys will be exposed to this compounding interest when you guys get a full-time job and every employer had their 401k match, and then you have to invest in certain commodities or type of areas where you are investing your money, 401k money in. So that's when this compounding interest of term or having this knowledge of compounding interest will be very useful for you guys as well in your personal finance management as well. Yeah. Forward. So either you can do these detailed calculations 1 year at a time using your actual calculator, pen and paper, or individually in an Microsoft Excel file. Yeah, you just create your structured tables and add formulas and keep on adding year after year after year. Or you can use some simple Excel formulas the one we are seeing here. So let's look at this formula. So the future values equals to present value multiplied by 1 plus r raised to n. So here r is your interest rate and your n is the term you are using. So oftentimes in the industry, if there is a big asset you are purchasing, say $5 million, again that asset will have some working life. So yeah, that will be your n. And oftentimes that asset is usually purchased on loan amount. So you'll be you'll try to find out how much that will cost over a period of time and so on. So that's when the formula like this will be utilized. Yeah. So if you look at this closely, actually we are doing the same thing that we done in our previous two examples that we saw for simple interest and a compounding interest. Just that we are doing it 5 times here in manually versus this is a straightforward formula. So again, so our amount today is $1,000 and I'm entering those values in this formula. So R is my 0.1 raised to 5. So I'm getting the answer as 1610.5 and that's the exact number I got. So instead of doing this manually, here we are just using a standard accounting and financial formula to get the same answer. So similar to this, this is a formula to calculate the future value if the present value is known. And if I know the present value and I want to know the future value and I have all the information, I'll be doing the reverse thing. Now we calculated this amount using compound interest methodology. Something more. So third scenario is where the amount today is $1,000 interest rate. I have 10%. The term I have is like 5 years, and I want to know the value for future. So instead of doing like 1 year at a time, I can simply use this formula, accounting financial formula, which stays future value equals to present value multiplied by 1 plus r raised to n. And here r is your interest rate in percentages and n is your term, that is 5 in this case. So I'll just plug in these numbers, 1000 multiplied by 1 plus 10 divided by 100, which is 0.1 raised to 5 years. The value I get is 1610. So this is exactly same value I have over here. So this is a simple formula that we can use and get the same answer within less number of steps. So if you look at this whole methodology of calculating the future value, if you know the present value and you know the interest rate and the terms, so this is the methodology we use. So from in the problem we solved, it's from $1,000 after 5 years at 10% interest rate, the amount of the future value will be 1610.5. And this process of calculating future value, if the present value is known, is called as compounding. And this is your compounding formula, future value equals to present value multiplied by 1 plus r raised to n. And the reverse process, if I know the future value and if I know the interest rate and I know the the term for what I'm looking for, I can do this in a reverse manner. So plug in So in this case, we know the future value, we know the interest rate and term. So all I have to do is reshuffle these terminologies. So my present value will be future value divided by 1 plus r raised to n. And that process is called as discounting. So this is how I will be getting. And this is the formula that we talked about. So it's the same formula, future value equals to present value multiplied by 1 plus r raised to n. And if you are you're backtracking it, if you're trying to predict or if you want to know what was the present value of a certain asset or certain value of money for a given interest rate and a term, this is the formula you'll be using, and this is called as a discounting. Yeah. So this is the most basic theory that we need to know to solve all the Excel assignments we are going to solve for the scope of this class. So let's get started over there. Let us convert the present value, that is amount today of $1,000, to its equivalent future value in 5 years time with a simple Excel formula, which looks like this. So yeah, the syntax is equals to FV, and in the bracket we are seeing some terminologies. So the first one is a rate. So in this case, it's interest rate 10% in our case, N per interval. Yeah, so N is the term. So in this case, it's 5. For now, we are going to ignore this entity PMT payment and also the type. So yeah, these two PMT and type has relevance in some future like bigger problems we'll be solving. So in this case, for simple formulas of FE calculations, we have to ignore the PMT and type. So yeah, let's ignore those and moving forward with the PV. So yeah, the present value is 1000 over here. So this is, yeah, the simple formula. So I'm going to start using it. So I'm starting with equals to FV tab formula started. First is I'm entering the rate, which is 10%, starting with a comma, then I put a comma, then end term. So that is 5, comma. And since we are going to ignore the payment, I'm going to add one more comma. That means that I'm ignoring this part and moving forward to the next one. So my present value amount today is 1000. And then I'm going to ignore type. So I'll just add a, yeah, close the bracket and enter. Yeah. So that tells me for my amount today, my present value of $1000 with these conditions, my future value will be $1600, and that's exactly what we saw in our previous yeah, when we were solving the problem mathematically using the formulas. So yeah, this is the amount, and similarly I can do the same for yeah, predicting my present value if I know the future value. Yeah. So let's get to this next sheet over here. So I'm clicking on this sheet PV. And hey, some more things over here. So yeah, here are the short forms and explanations of what these terms are. Rate, the interest rate per period. NPER is the total number of payment periods. PMT is the payment received each type, which we are ignoring for this. Yeah, it will be used in future. And for solving problems like these, you don't need PMT and type. And fourth is FE is your future value. That is the cash balance you want to attain at the end of that period. Yeah, number of payment periods. And type is, yeah, when payments are due. 0 equals to end of the period or beginning of the period is 1. Yeah, which will be ignored in our case. So yeah, coming to our main problem. Moving forward with the next part, which is predicting your present value or knowing your present value if your future value is known. If your future value is known, so this is the syntax we use. Equals to PV, start with the bracket. The first one is rate, and here are the elaborations, explanations of what these are. The first one is rate, interest rate per period, and P as a total number of payments. Again, this everything same. So coming back, in this case, yeah, I'm trying to know, I know the future value, and I want to go back and check what was the present value at the start of this term 5. Yeah, so I'll start equals to PV tab, starting a formula. So first one is a rate. I'm selecting this cell that says 10%, comma, NPER, which is the term, comma. The next part, which is PMT, I'm ignoring it. So I add one more comma, and then the amount, future value amount, that is this cell over here, B5, and then I'll close. That means I'm ignoring the type, and it gives me my present value is $1000. Yeah, so this is how you'll be solving this problems, where either your present value is known and you know some more conditions and you have to predict a future value, or the reverse, if your future value is known and some other conditions and you want to know what was the starting point, that was your present value. This is how you'll be solving these problems. Yeah. And in financial world, this is one of a simple but very highly used formula, or highly used concept. So for you guys to get this exposure early on is very important. Before moving forward, we got to revise the concept of annuity. Annuity is a constant annual amount for multiple periods. So if you have invested in a project, for example, from where you will receive annual installments, annual equal installments, we will call that as an annuity. Now the point is how to calculate the present value of an annuity. Whatever the amount is, I mean the annuity amount, multiply that with annuity factor and you will get your present value. Now this annuity factor can be calculated using this formula shown over here, where R is the discount rate and N is your number of periods. So let us take an example for say so there is a company. So our company is expected to receive $100,000 per annum for 5 years, and the discount rate over here is 10%. So we know that the present value of an annuity can be calculated using this formula. So yeah, equals to present value of annuity equals to annuity multiplied by annuity factor equals to annuity amount multiplied by this formula we saw in the previous slide. So yeah, just plugging those numbers. So annuity amount is 100,000 multiplied by, yeah, plugging these numbers, R becomes 0.1 and becomes 5. And yeah, just solve for it and you'll be getting this amount as 379,000 and yeah, $79. So we would say that the payment that you will receive like $100,000 each for 5 years, roughly speaking, that will be 500,000. But when you convert that to your present value, it is equivalent to $379,000 and $79. So yeah, that's your present value after 5 years. Now, definitely we don't need to understand and use this formula. Yeah, like technically we won't have to use this formula. We will be using Excel. So let's solve this type of problem in Excel. Let us solve the same scenario, but this time we'll be using Excel to solve this problem. So I would say yeah, equals to, yeah, here in this case, yeah, this is the same formula. Equals to PV and bracket. First is rate and next one is NPER. Next one is PMT payment, and next one is a future value and type. And again, these are the explanation of what each of these terms are. So in this case, yeah, this is exactly same formula in Excel which we saw while solving for PV. But there are some other terms we are going to ignore and go. So we are going to use some of these terms. So let's get started. So in this case, yeah, I will start with this formula equals to PV tab. So my first one is a rate. I'm starting with 10%, comma. Next one is NPER, that is terms. I'm using 5. And next one is very important here. So the payment here, right? So the number of payment, like yeah, period is 5, and then the next one is the payment amount with this argument over here will mean that this payment is going to be repeated. Yeah. So in this case, we definitely know 100,000 is going to be paid for a period of 5 years. So I'm going to select this cell. The next one is a FE. In this case, we are ignoring. So I'll just add a comma over there. And the last type is another important. And as soon as I do that, when yeah, there are a couple things that are highlighted, which says that 0, that is end of the period. And if I select 1, that is beginning of the period. Yeah. So again, if I pick 0, it will give me the amount that will be the present value for end of the 5th period, versus if I say 1, it will be at the beginning of the 5th period, meaning at the end of 4th period. So again, depending on which one I pick, 0 or 1, I'll be getting two different numbers. In this case, 0 applies because we are looking at the end of the 5th period. So I'll select 0 over here and close the bracket and say enter. And this is the amount I got. 379,000 and yeah, and $79, and that's exactly what we did during our calculations. In this part, we are going to calculate the future value of an annuity. What does this mean? Let me explain you. So here you can see that we have 5 annual installments of $100,000 each, but we want to accumulate them all together at year 5 and see what is going to be the value at year 5. So the background working would be that if you are saving an installment at end of each year, so year 1, year 2, year 3, year 4, and year 5, you can invest that at the end of each year. Yeah, year 1, 2, 3, 4, 5. And here you can also invest the interest that you receive at the end of those respective years for 2, 3, 4, and 5, and so on. So the first installment, in fact, the first 4 installments that we would receive, we would be able to earn interest over those. So let us calculate the future value. Now, this is going to be the formula that we use. So this is the same FV formula we have used in the past. Yeah. Equals to FV tab. I'm selecting the rate as 10% or cell B6, comma, NPER, that is term 5, comma. Again, the payment that I'm going to receive is 100,000, comma. I'm going to ignore the PV part and I'm going to select at the end of the year, end of the period, which is 0 back. Yeah, this is the amount that we got, 610,000 and $510. Now, to show you what does this mean, what does this value exactly mean, let me calculate this value for you without using Excel formula. So here I'm going to say, let's start over here. So here we'll start with 10000. 100,000 for year 1. Same thing for next 5 years. So I'm going to say Control C and going down. Oops, sorry, did it all. 2, 3, 4. Yeah, so it makes total 5. So these are the 5 years I'm going to receive $100,000. And on top of this, suppose this is the first installment I get for the at the end of year 1. I'm going to invest it for year 2, 3, 4, and 5. Yeah, so for the next 4 years, I'll be investing it. So 1, 2, 3, and 4. Yeah, so again, this is my year for this much amount that will be invested. So 4. Next one, I can only invest at the end of this term 1, 2, 3. So it will be 3. Next one will be 2. Next one will be 1, and next one will be 0. Yeah. So these are the terms I will be investing the amount I received. Yeah. So again, in order for me to calculate the actual amount that I will be receiving plus the interest for the remaining number of years. So this is the formula I'll be using, equals to, say I'm going to use this number, cell E5. So yeah, I'll just select those. Multiplied by, say, 100% multiplied by, plus the interest, which is my B6, 10%. I'll close the bracket, raised to my term. Yeah, so the term for which I'll be investing those. So in this case, my term is my cell F5. Yeah, so this is the term I'll be investing it for. So I'll press enter. So this is the amount I'll be getting. If I have to invest the amount I received at the end of first year and I plus the interest, and at the end of fourth year, or sorry, end of fifth year, the total amount I'll be getting is this $100,000 plus the interest for all the remaining 4 years. Yeah? So that's what this means. Yeah. So again, copy paste this formula for the remaining as well. The only catch over here is I need to lock this cell, that is the interest rate. So I'll just select this and say function F4, so that will add dollars and that will lock it down. Yeah. So again, then I will Control C, and add to the rest 4. And this is the total amount I got. And here, if I sum this up, equals to sum, close it out. Yeah, that's the amount I got. Yeah, this is the exact amount that we calculated using the simple Excel formula, that is FV, and enter these parameters as needed. So this is what it means. So this solves this part, which is getting the future value of annuity. And in terms of accounting and financials world, or if you are getting job in that, this is a very commonly used term. This is good for you to know. And in this stage, for the scope of this class, do you need to understand each and every detail of what annuity is or future value is, present value is? The answer is no. Just follow my guidelines and solve the problem. And that should be good enough for you to prepare for your next step if you're looking for internships, or like if your job already involves calculations like these are the easy ways to use and get very complex formulas solved within few minutes.